All right. So, continuing on with proofs. So, as you can see there at the top, remember that if a theorem has a specific name, it's something that you're going to need to memorize. All right. And so, review every 5 to 10 minutes or 5 to 10 minutes every single night just to get familiar with what the names of those are and what they actually mean. Oftentimes, they're very similar to just the definitions of something in the pretty common sense, but you want to just have circled back to them each day as a reminder, and they'll just kind of be in your mind as you are figuring these things out. And so just please spend the time. It is worth it. Okay, so let's try another one out. This one's from Scratch. And so again, I've talked to you about doing some planning, some pre-work in order to just try to give you a little bit of an idea of potentially some things you might include in your proof. All right. So if you take a look at this diagram over here, I got angle 1, 2, 3, and 4. I have a triangle. All right. So some things that I noticed just looking at it. Okay. I see that, okay, angle 1 and angle 2 are a linear pair. All right, so I understand what a linear pair is, so I'm able to see that. I also know that linear pairs are supplementary, okay, meaning that they add up to 180 degrees. All right, so I could even do that. Linear pairs add to 180 degrees. Triangles add to 180 degrees. All right, so these are just some things that I'm observing about this that might be helpful in my planning. Okay, I may not use them. I may use them. I don't know. All right, so let's take a look at step 1 here. Okay, and so the first thing that I should always do, okay, is I'm going to write the given, okay, as my first step here. All right, so just simply write the sum of the angle measures in a triangle are 180 degrees. All right, and the reason, well, that is given to me. So that's my starting point. So that is always the first thing that I do. And I'm trying to prove that the measure of angle 1 equals the measure of angle 3 plus the measure of angle 4. All right, so taking a look at that, I'm trying to say that, okay, angle 1 equals angle 3 and angle 4. Okay, and so we want to be able to reason our way to that conclusion. And so let's see if we can figure out how those things are related. Okay, so we can look and say that, all right, our second one that we can say is that, all right, well, let's just kind of establish some bits of information. All right, so we got angle 2 plus angle 3 plus angle 4 equals 180 degrees. Okay, well, why? Because the measures of the angles in a triangle add to 180 degrees. Okay, and so it's kind of what we understand about angles and triangles. And so I could just simply put that in there. So I'm really kind of listing things out that might be helpful in kind of building a case. Okay. All right. So what can we say next? Well, we could say that angle 1 and angle 2 are a linear pair, right? Well, we know that by the definition of linear pairs. Okay, we got a straight angle, just a straight line. Okay, that adds up to 180 degrees. We got two angles that have one common side with each other that are adjacent. All right, so we have a linear pair. And so, as I just alluded to, all right, well, the measure of angle 1 plus the measure of angle 2 equals 180 degrees, right? That's the linear pair theorem. Okay, and so that just tells me that they are supplementary. Okay. All right, so definitions kind of help me identify them, and then I got theorems that help me maybe draw some conclusions from those. All right, so let's take a look at maybe the next thing that we can do. Well, I notice in step 2 and step 4, I have the measure of angle 2 as a part of it. And so, all right, maybe they each equal 180. Then maybe what I could do is set those equal to each other. So I see that the measure of angle 1 plus the measure of angle 2 equals the measure of angle 2 plus the measure of angle 3 plus the measure of angle 4. Okay, and what I notice, okay, is that what I notice about that is that I have a like term on both sides of that equation. Here we go. All right, so I see each of those on both sides. Okay, well, essentially what I'm doing is I'm going to cross that out. Okay. I was able to figure this out because I simply substituted. Okay, so this is the substitution property. Okay, if they're both equal to 180, then I just kind of removed the 180, plugged in the values there. Okay, and since measure of angle 1 or angle 2 is on both sides, I can essentially cancel them out. I'm going to end up with the measure of angle 1 equals the measure of angle 3 plus the measure of angle 4. Okay, because I just simply subtracted subtraction property, not subtracted. Subtracted the measure of angle 2 from both sides, and therefore, okay, the measure of angle 1 must equal the measure of angle 3 and 4. All right, so we can kind of see the thought process. All right, I did some pre-work that helped. I ended with the prove at the bottom, and I was able to kind of build a case with information that then I was able to kind of consolidate. Okay, with that substitution, I kind of plug something in. Now all of a sudden I see how they're related to each other, and then I can draw a conclusion there at the end. All right, so hopefully that started making some sense. All right, so let's take a look at this next bit. Okay, lesson 2.7. All right, just some more practice here. So we're looking at common segments theorem. Okay, this is given that collinear points A, B, C, and D are arranged below, and segment AB is congruent to CD if and only if segment AC is congruent to segment BD. All right, so we can see here that AB and CD are congruent. We got the tick marks to show that. Okay, and so that's telling me that they're equal length. So our conclusion is that AC is congruent to BD. Okay, and so what that means is that right here in the middle, this spot between B and C, okay, this is a common segment. Okay, so essentially what you're doing is you're adding the same amount to equal segments should create equal new segments. Okay, so it's just saying since A and B are equal to each other, if I add BC to AB, okay, then AC, okay, will then equal BD because I'm going to add BC to CD. Since that's the same common side and CD and AB are the same, then I can conclude that AC and BD are actually equal to each other. That's what this is trying to tell me. Okay, got the same common part. The other part is equal. Then the segment, when you add them together, will also be equal. All right, so let's prove some of this. So if AB is congruent to CD, then AC is congruent to BD. All right, so let's start there. So we got just a lot of numbers, a lot of letters, okay? And they really should have symbols above it, line segments. All right, but since we're only dealing with line segments, we can conclude that that's what these things represent. So the statement AB equals CD, okay, well, the reason is, well, that's given to us. There's step one. You always make sure you're doing step one at least, okay, because that's given to you at all times. Okay, so if they're congruent to each other, okay, then we can say that they are equal to each other, and that's the congruent segments have equal length. Okay, so sometimes I get a theorem, a postulate, a property, sometimes a quick and a brief statement is also given to describe the reason. All right, BC equals BC. Well, it's the same thing, and so we saw in our big long list of properties that this is the reflexive property. Okay, BC is equal to BC. Great. Well, then if AB plus BC should then equal BC plus CD. Okay, so we added the addition property. And we added BC to both sides. Okay, and so we look now and see that, all right, well, AB plus BC equals AC and BC plus CD equals BD. Okay, this is just simply the segment addition postulate. Okay, you could also have said sum of the parts equals the whole. Okay, either one is fine. All right. All right. So then what we're seeing now with step 6 is that I took AC and I plugged it into here, okay, to equal BC plus CD. Well, how do I do that? Well, anytime I plug something in, it is the substitution property. Okay. And so this really is step 4 and 5 working together. Okay. Then, after I did that, I'm able to then create that statement, that substitution. Okay. And then again, we're going to take this part, okay, and we're going to substitute it in for that part. Okay. And that's how we're going to end up down there. Okay, and so what do we have to do? The substitution property again. But in this case, it was step 5 and 6 combining together. Okay. And so remember, okay, that 3 dot symbol means therefore. It's usually given right at the end. It's basically saying because of all this, we can conclude, etc. So therefore, this is true. Okay, and so we can say that equal length, okay, are congruent segments. Okay. All right, so at first, all blank seemed really quite intimidating, but if you break it down and use the diagram and check it out, you can start to see, all right, I just added something. Well, if something's equal to itself, that's a reflexive property. If I take segments and add them together, well, it's a segment addition property. If I plug something in, that's going to be substitution. And you find that, oh, most of these reasons aren't that bad. Now I get that maybe 2 and 8 might be a little bit harder to kind of fill those things in exactly, but many of the rest are relatively straightforward. Again, the more times you practice this, the more you're going to start seeing those consistencies, and then you're going to be able to start filling these things out yourself, which we'll get some practice here coming up. Okay, so we got another theorem. Okay, we've learned about vertical angles already. Okay, and so if two angles are vertical angles, then they are congruent. All right, so remember, vertical angles are made when two lines intersect at a point. So the opposite angles that are created are equal to each other, okay, and they are vertical angles. So we see here with this diagram, 1 and 4, they are opposite of each other, are vertical angles. Therefore, they are equal to each other. Okay, and then 2 and 3 are vertical angles. Therefore, they are equal to each other. Again, these arc marks are just to show relationship between the fact that a 2 and 1 has no bearing on the actual angle. Okay, but once I mark one arc mark, if I want to mark a different angle, well, I use 2 if it's not the exact same value. All right, so we know if they are vertical angles, then they're also congruent. Okay, and so if two supplementary angles are congruent, then each angle is a right angle. Okay, so that makes sense. If they're supplementary that add to 180, two angles that are the same, the only option is that they are actually right angles. Remember, right angles equal 90 degrees. Okay, so you can see here, right, that the measure, if I label this angle 1 and angle 2, right, I got a right angle there, got a right angle there. The measure of angle 1 plus the measure of angle 2 equals 180. If the measure of angle 1 then equals the measure of angle 2. Okay? So they are right angles. All right. Okay. So let's prove the vertical angle theorem together. All right. So I know that these are going to be congruent pairs. Okay. So if 1 and 3 are vertical angles, why? Well, that is given. Great start. Okay. 1 and 2 are linear pairs. How do we know that? Well, by the definition of a linear pair. Okay. They are supplementary. Well, we know that by the linear pair theorem. Okay, it's kind of the second time we've used this. So when they say they are something, well, then that's just the definition of it. Now, if we draw a conclusion about it, well, that's because of a theorem. So 1 and 2 are supplementary. That's because of a theorem. If that is the case, and since they are kind of sharing one of these, okay, we can say that they are congruent to each other, and that is by the congruent supplement theorem. Okay. Maybe you did another step in there that you could have said maybe the transitive property or something like that to set 1 and 3 equal to each other. Not a big deal. just as long as we kind of get to the end and the reasons and statements that we give are truthful. Okay, then you might be able to have some wiggle room to have different number of steps in between them. Okay. All right. Okay, we've done some of this. This is, again, a lot of what you're going to see in terms of geometry. Okay, how kind of algebra and geometry overlap. So you're going to use a diagram or shape that's going to have algebraic expressions representing their value, and you're going to have to reason your way through to find the value of x, or how big the angle is, or the arc, or the chord, or secant, or all these other terms that we'll eventually get to. Okay, so if we look at this, okay, we know since they are vertical angles, okay, then they are equal. They are congruent to each other. So I can set 3x minus 40 and 2x minus 10 equal to each other. Well, if I solve by subtracting 2 and then adding 40, I'm going to find that x equals 30. Okay. And so if x equals 30, then I could plug that in and say, all right, 3 times x is 30 minus 40 gives me a 50-degree, okay, a 50-degree angle. If I plug that into this side, I get 2 times 30 gives me 60 minus 10, and it confirms it's a 50-degree angle. That's an acute angle. So visually, that seems to make sense as well. All right, so if I look over at this one, okay, I got a few options on what to do. And I think we've done this example or a similar one to this. I could look, let's call this 1, we'll call it angle 1, angle 2, angle 3. Okay, and then I will know that those are a linear pair, so they're going to add up to 180. So I could say 4x plus 1 plus 7x plus 3 equals 180. I'm going to get 7x plus 4 equals 180. 7x equals 176. X equals 16. I think this is the exact one. So there's also other ways you can set 2 and 3 equal to 180. So you do 7x plus 3 plus 65 equals 180. You would then subtract 68 from each side. You would end up with, what's that, 112 equals 7. X, you divide by 7, and you would end up with 16. So no matter what way you go, you will end up with 16. Okay. All right, if I look down at this one, okay, if I see that, let's just label this 1, angle 2, angle 3, angle 4, angle 5. All right, so if angle 1 is 45, then I know that angle 5 is going to be 45, angle 3 is going to be 45, and therefore those are going to be 45. Or sorry, not 45, 90. All those are 90. So if that's the case, then 4y plus 6y equals 90. Okay, so 10y equals 90, y equals 9. Okay, so I can plug that back in. This is 54. This is 36 degrees. Okay, so it's using our understanding to solve for something and then be able to plug that back in order to solve for an exact answer. Okay, we're going to see quite a bit more of that. All right, doing great, almost done. All right, let's do one more proof together, right? So this image is starting to look a little bit more complex. I got parallel lines. That means 2 lines that will never touch each other. And then I have one intersecting line going all the way through it. So there's some things that, because of that, because they're parallel lines, we can make some conclusions. Okay, and so I can see, let's say I name this line A, line B, and line C. Line A and C are parallel to each other. B is the intersecting line. Okay, and so each of these will create vertical pairs. So we know that 1 and 2 are vertical pairs. That means they are congruent to each other. Okay, and so that means 5 and 2 are then linear pairs. And then if I had labeled this other one here and 1, those are linear pairs. So they're going to add up to 180. Okay, and so then I know that these 5 and 3 are actually going to be equal to each other. So 4 and 2 are equal to each other, and this one is equal. So all of 4 of those are equal in value. Okay, and then I can see that 5 and 3 and 6 are also equal to each other. Okay, so whatever those actually are, okay, they are equal to each other. Okay, so you can start to see there's a lot of symbols that could be on any given diagram to help you keep track of it. Okay, so we have our given information. So where's the reason? It is the given. Fantastic. Okay, so angle 1 is congruent to angle 4. We see that with the arc mark. Awesome. Okay, so we see then that 1 and 2, okay, are congruent to each other. Well, we know that because of the vertical pair theorem. Okay, so you might be wondering, like, all right, vertical pair theorem, why isn't it not just the definition of it, right? The definition is basically identifying, okay, that those are vertical pairs. So if number 2 instead said, okay, angle 1 and angle 2, well, they're not vertical pairs. So let's say it said angle 1 and angle 5 are vertical pairs. Then my reason would be the definition of it. Okay, but I'm drawing a conclusion and a relationship. Okay, and so that's more the theorem part. So just trying to help you differentiate between when I'd use the definition and when I might use a theorem that have very similar names. Okay, so if 1 and 4 are congruent and 1 and 2 are congruent, okay, then I can set, okay, 2 and 4 as congruent to each other. Okay, and that's the transitive property. We have kind of two separate things that are equal. One of them, they share a part together, and I could just sandwich them together. Okay, maybe you would have thought, isn't this just kind of substitution where you're putting into? You know what? You could have put substitution in there, and I think that would have been legitimate as well. Okay, so because those things are equal, then we know that the measure of angle 2 is going to be equal to the measure of angle 4, right? Because congruent angles are equal in measure. Okay, just like we've been saying since the beginning. What's another word for congruent? Equal. Okay, so we can draw that conclusion as well. All right, so looking back up, we see that angle 4 and angle 3 are a linear pair. Well, that's where we use the definition of a linear pair. Okay, as my reason. Okay, so we're still talking about the same pair. So the measure of angle 4 plus the measure of angle 3 equals 180. Well, that's just the linear pair theorem. All right, so we're drawing a conclusion, relationship, something specific about it, the measurements. That's more the theorem part. You just identifying they are a vertical pair. They are a linear pair. That's the definition. All right, so then we look at 2 and 3. Okay, we find those are 180 degrees. Okay, well, we figure that out through substitution. The substitution property. All right, so if I look at step 4, I see measure of angle 2 equals the measure of angle 4. Okay, if I look at step 6, okay, I see the measure of angle 4 plus measure of angle 3 is 180. Well, if 2 and 4 are equal, then I could just plug 2 in for 4 and conclude that the measure of angle 2 and the measure of angle 3 equal 180 as well. And so because of that, if we know that to be true, well, therefore, that's the 3 dots there. Okay, angle 2 and angle 3 are supplementary. All right, because two angles whose measures add up to 180 are supplementary angles. All right, so we drew some conclusions, had some theorems, some properties, okay, and try and moved our way from our given, our start, to our end, which is our proof. Okay, so listing out some things, making a plan, identifying some things on the diagram will help you draw conclusions to be able to actually write a proof. All right. So you got some more proof practice that we'll probably do in class together. You got your homework that you can be practicing on as well. Okay, to get as much exposure and practice doing this as possible. So try your best first and then go and check and see, all right, well, maybe my order was a little off. Maybe I forgot the name of something. Maybe I missed something in the diagram that I'm going to need. All that's really, really valuable, but you got to attempt it. Don't just copy stuff down. Don't just turn your mind off and write down what you see me do or you see a classmate do, because you need to spend the time thinking about it and trying to reason in your own mind in order to be able to create one of these yourself. All right, so make sure you got these things down. Take some time to go back through your notes and just read through it. Try to remember what some of those things are. You can write the names down on a piece of paper, as well as just kind of maybe a visual to remind you of what those are. Because maybe if you saw the name, you can kind of understand and verbally say what they are. That's a good way to kind of commit it to memory. Write down the name, okay, and then be able to kind of describe what it is to somebody else. All right. Hope this was helpful. Thanks for watching.